My name's Dave Pemberton, and I'm the principal at MedFab3D. I would like to welcome you to our chalkboard talk today. What is 3D printing? 3D printing is another name for additive manufacturing. Additive manufacturing is a set of processes that manufacture a part by adding material. This is the opposite process of machining, where material is removed for manufacturing. "3D printing adds material one layer at a time. Next, we're going to go over the parts of a 3D printer. A 3D printer has an extruder, a gantry with 3 axes, an x-axis, a y-axis, a z-axis, and can move in 3 directions. The 3D printer has a heated build plate that the material is extruded upon to make the part. It has 3D filament, which is used as the source material for the part, and a guide system that guides the 3D filament to the extruder. This is time-lapse photography of a 3D printer manufacturing a part. You can see that the extruder extrudes plastic on the platform, and the platform, in this case, lowers one layer at a time, so the extruder can keep building the part layer upon layer. This is video of the same 3D printer making the part in real time. And this is the start of the process, where you can see the printer move off the bed to the right, and it's purging material out of the extrusion head. And then it moves to a center position and it starts to perform an outline. And the outline is actually offset from the part. This won't be part of the part. And what it's doing is purging material through the nozzle, stabilizing the plastic flow onto the bed, so that when it goes to print the part, the first layer of the part, that we have a steady, consistent plastic flow and the part is fully printed. The printer has completed the first layer on the part and has moved to the second layer now. You'll notice that it performs another outline, then moves to the interior of the part and fills in the interior with material. This is analogous to coloring between the lines on a coloring book. We've added a visualization tool to the screen so you can see the moves of the print head as it moves across the bed. The printer has completed the third layer of the part and has moved up to the fourth layer now. You'll notice that as the printer is printing, that the layer is printing quicker than the layers before it. This is due to 2 reasons. One is that we print the initial layers on the part slower in the beginning to allow for better adhesion to the bed, to make sure that we have a good foundation for the part. The second reason is that when we print the part, it's not a solid fill. In this case, we're using a 30% infill pattern, and you can see that it's diagonal as we're going across the part. This does 2 things. It lowers the overall weight of the part and reduces the amount of material that is used. It also decreases the amount of print time that is involved to print the part. We're going to watch a few more layers of the part being printed at normal speed, and then we're going to accelerate the video to get to the end of producing the part. And that's really all there is to it. It's not any more complicated than that. There's a lot of mechanics about setting the printers up and operating them correctly, and the temperatures and the processes that we use to extrude the materials. But the process is straightforward to produce a part. We wanted to show you the final part that was produced, which is a 20mm calibration cube. We used the calibration cube to check how well the printer is performing. We also wanted to show you a close-up of the same part that shows the cross-hatched infill pattern that we used to print the part with. Thank you for joining us for our chalkboard talk today. If you like this video, please give us a like on YouTube. And if you'd like more information about MedFab3D, go to www.medfab3d.com.